In this video, I'll do another example of graphing a piecewise function. The other video is too long, so I decided to split it, and this could be another helpful example to watch. So I see here that my function is called h of x, and that I have 3 segments, and I'm going to use vertical dashed lines to divide my graph up. So the first segment happens when x is less than -7, and so I'm going to draw a vertical dashed line here at -7. And then I have another segment between when x is -6 and when x is 0. And then my last one is when x is greater than 0. So what's interesting here is that we have 4 segments, even though we only have 3 pieces, which means that there will be part of this graph where x is not defined at all. It's undefined for that section. So the first section is when y, or h of x, is -4. And I notice here that I'm going to have an open circle. So I could just jump to doing that, knowing that I don't really need to do any calculation. Or for good measure, I could put in my table. So when x is -7, y is -4. That's my boundary point. And then I need another point when x is less than -7. So I'll put -8, -4 there, just to help myself out. Then we have the next section where we have between x is -6 and 0, and we have 7 minus x over 3. So I'm going to make myself a table here, and I'll leave some workspace in the middle so I don't make any silly mistakes with signs. So I have 7 minus x over 3, and I have -6 and 0 as my boundary points. So 7 minus -6 over 3, well, that becomes 7 plus 2 is 9. And then 7 minus 0 over 3, 7 minus 0 is 7. And if I look, I see this inclusive and then exclusive inequality here. So I know that I'm going to have a closed circle and then an open circle. It is good practice if you want to practice labeling those. So I could have gone back and I could label this open so I didn't accidentally make a mistake here. And so I'll do a closed circle at the point -6, 9, and an open circle at the point 0, 7. Oops. And I can double check here. Oops, I did a closed circle there. An open circle, there we go. So I can double check using the y-intercept and the slope. So my y-intercept is in fact at 7, and my slope is -1/3. So I feel good about that line segment. It's a little hard on Notability to get it to be exactly -1/3. There we go. And then we have the final segment here. I will use purple as a third color. So I'll make my table. And in this case, we have 2/3 x. We have a boundary of 0, and then we need another point where x is greater than 0. I'm going to choose a multiple of 3 so that I don't have any fractions. So we have the point 0, 0, and then we have 2/3 of 3, which is, of course, 2. And we will have a closed circle right here because we have an inclusive. We have a greater than or equal to inequality. So I will have a closed circle at 0, 0. And then I have the point 3, 2. Now, I also could have just used the slope and y-intercept to either check this or add more points here. And so I will use the vertical line test to make sure that I don't have, I don't have any 2 points on the same vertical line. So for example, at 0, I have an open circle and a closed circle, so that's okay. And we do see, it is worth pointing out, that if I asked you for any value between when x is -6 and -7, it is undefined in here. It is defined at the point when x is -6, but actually not when x is -7. So that is something that I could ask for. And so then we'll evaluate the function for these given values. So h of 0, that is in our purple section. We have the point 0, 0. It is both in our table, we see it on our graph, or you could have gone back and used this inequality here because that is the domain that includes the 0. And so we'd have 2/3 of 0 is 0. Then we have h of 1. I could look on my graph and I can see h of 1 is at 2/3. It might be hard for you to note that. So and the h of 1 would be using this inequality right here. So I would have 2/3 of 1, which is 2/3. And then h of -12, well, we can see that this segment is continuing on, Or we can go and we can say, oh, that is in the blue section. And so h of negative 12 is negative 4. And again, I just want to say, like, if I did ask you for h of negative 7, for example, that would be undefined because there is no h of negative 7 on our graph. It's an open circle. And we see that it's not actually part of this domain or this domain here. All right, thanks for watching.